Hello friends, welcome to this session. Today we are going to discuss the physics analysis of this NEET test 54 and then we'll move to the solutions of the paper. Now I have done it right now in the morning, and from the paper I can see it is slightly tougher from the yesterday's one. There are few questions which are difficult. Actually difficult means the theories which generally students don't remember. 34th question is the pick of the question that will be the toughest for all. Most of you won't be remembering that particular results or the way of doing this question. In question number 11 the answer is 3.9, but they have printed as 39, but you can make out from the option that it should be 3.9. So I'm not saying it is wrong, it's just a typo error. So apart from that, 15 were easy, 24 were medium, 5 were difficult. So again, it's a overall not very tough, but slightly a slight testing paper, you can say. So here again, for an average or a good student, average student, the good score I think should be 135 plus, and for the exceptional students, a very good score will be counted as 155 or 160 plus would be very good score. So that is about the analysis. Now let's move on to the paper. So let's start the paper. See the question number 1. Time period of vibration of two bar magnet in sum and difference position are 4 and 6. The ratio of the magnetic moment is. First of all, I know the magnetic moment in some position is m1 plus m2, and in the difference it is equal to m1 minus m2. And we know the time period is 2 pi root I by what we say it is mu b means here mb. So what I can say, the ratio of t sum to difference, because all things remain same, because in sum and difference I is same and b is same, so what we have, it is 1 by root m, so it becomes m difference means m1 minus m2, m sum means m1 plus m2. So this is 4 by 6, I can directly write 2 by 3, so squaring it would be m1 minus m2 over m1 plus m2. So doing this, what we have, 4m1 plus 4m2 is 9m1 minus 9m2. So now what I have, if I take this, 13m2 is equals to 5m1, so m1 by m2 comes out as 13:5, that I can write as 2.6:1, so go for option C. Next, in the given figure, the value of voltage, so just let me have this figure, let it be A, let it be B, let it be C. So if it is C, this is the wire going, this is C, let it be D, this will be D, and okay. So first redraw it. So what we have, between A and C I have 4 ohms, between C and D I have a parallel combo of 3. I have this 20, I have this 100, and also I have this, what it is, 25, and again now between D and B what I have is 6. Now 5 ampere flows like this. So common sense says this is also 5 ampere, so 5 4s are 20 volt drop, 5 6 are 30 volt drop. And now 3 are in parallel, combined current would be 5, so I can make out the parallel combo. So parallel would be 1 by 20 plus 1 by 100 plus 1 by 25. LCM is 100, 5 plus 1 plus 4. So we get it, this RP will comes out as 100 by 10, that is 10. So this is 10 ohm, 5 ampere goes, so 10 into 5, this drop would be 50 volts. So 20, 50, 30. So that is 100 volt, go for option B. Next, if the resistance of the potentiometer wire is 15 R, then calculate the balancing length. So first of all, this is 15 R, this is R. So first look at the primary circuit. What is X? X is VAB by L. VAB is RAB. RAB is 15 R upon total R, which is 15 plus 1, 16 R into E divided by L, that is 15 by 16 E by L. Now for the balancing this secondary cell, this R doesn't have any meaning, because in the balancing length no current flows through it. So I can directly write E by 2 is the measuring one, that should be equal to XL. So putting this, E by 2 is X, X is 15 by 16, E by L into L. So E and E get cancelled, L comes out as 16L upon 30, which is 16 into what it has, 600 by 30. So this is what we have, this is 20 into 16, 320 centimeters. So go for option A. Next, the reading of the ammeter and voltmeters are both in measures RMS. AC circuit is given. First of all, XC is 2, XL is 2, that means circuit is in resonance. So if circuit is in resonance, IRMS I know that would be measured by this, the whole IRMS, that would be VRMS by R, that comes out as 110 by 55, that is 2 ampere. Now this voltmeter measures the combined voltage. Here, because of resonance, voltages on both are same but out of phase, so this voltmeter measures difference of them. So this voltmeter will measure 0 at resonance. So go for option B. You must have done such questions before. Because it is at resonance, the question is not tough for you, it is a straightforward one for you. Next what we have, an inductor coil stores 32 joule of magnetic field energy and dissipates energy as heat as rate of 320 watt when a current of 4 ampere is passed. Now just understand the language. Generally what we have, we don't have an ideal coil, we have a coil which we treat as a combo of L and R. So what it says, when this current I goes, this is the rate, this is the energy stored in magnetic field, that is, this is the energy stored in inductor, which I know is half Li square, that is 32. So L comes out as 32 into 2 upon I square, that is 16, that comes out as 4 Henry. Similarly, dissipates as heat, that is a power dissipation by resistor, that is I square R, that is 320. So R comes out as 320 by 4 square, that is 320 by 16. I can write it as 20 ohms. Now what is the time constant when the coil is joined? That we know is equals to L by R, that is 4 by 20. So it comes out as 0.2 seconds. So again, just by the language you can make it out. You know this coil is depicted as a combo of L and R. Next one. Circular ring of radius r and uniform linear charge density plus lambda and kept in xy plane with its center at the origin, the field at the point. Okay, so it is placed in xy plane, let's say like this. This is x-axis, this is, let's say, y-axis, and let's say this will become z. Now the electric field at 0, 0, 0 r by root 2. Okay, I know the field at this point is maximum, if you can remember from your knowledge. Okay, but we have to calculate it. So the formula I know at the axial point is kqx. So x is r by root 2 upon r square plus x square, that is r square by 2 to the power 3 by 2. And what is q here? K I write it as 1 upon 4 pi epsilon. Q would be lambda into the length, that would be 2 pi r into r by root 2 upon, this will become 3r square by 2 to the power 3 by 2. So what I now have, this is 2 pi, so this will become 2. And so if I do above lambda r square, I get 2 root 2 epsilon naught I get, and what I get, 3 by 2 ki power 3 by 2 into r cube. Okay, so r would be in that thing. So this is 2 root 2, 2 root 2 will get cancelled. So what I will have, lambda upon 3 root 3 epsilon naught r. That is what I am left with. Is there any option? Yes, the first one is like this. So again, that's not a tough one. 7th, potential at A is 20 V is minus 20, work done by moving an electron slowly from B to A. So the W external, you know, is equals to Q delta V. Q is what we have, minus 1.6 into 10 to the power minus 19, and B to A, so that is VA minus VB. So VA minus VB would be plus, so minus 1.6 into 10 to the power minus 19, this comes out as 40. So answer would be negative. 40 into 1.6, that is 64, I know, that is minus 6.4 into 10 to the power minus 18 joule. So we have both the options, so you have to be careful, it should be negative 1. You always remember, electron by its wish always tries to go from higher potential, not to the lower potential. So if you're taking it to the lower potential, you are you are taking it from B to A, so sorry, you are taking it to higher potential, so it will be happy. Happy means potential energy will reduce, so W external would be negative. Now always remember, whatever the system wants, if the change is in that direction, we'll simply say its potential energy decreases, and if the change is opposite to the direction of the system's natural tendency, potential energy will increase. This fact will help you always. Now a charged particle moves through a magnetic field normal to its direction, then this is again the repetition, you know, magnetic field can change in momentum, can change velocity, but cannot change the kinetic energy or the speed of the particle. So kinetic energy changes, no, momentum changes, but the kinetic energy is constant. This is the most easy question. You must have done this question many a times. Charged particle enters a uniform magnetic field with a velocity vector at angle 45. Okay, pitch is followed as p, the radius of the helix will be. Okay, so what we have, pitch we know is equals to v parallel into t. Okay, so that is v parallel into t, and what is the radius? Radius we say is equal to mv perpendicular by qb. And here what you know this v perpendicular and v parallel will be same because angle is 45 degree. So I substituted, this is p, qb, and t. You all know what is t. T is 2 pi m upon qb, taking that qb above, qb gone, m and m gone. This is p by 2 pi. So again an easy one, just you need to be clear with your basics in this time. Now look at this question. This seems to be a lengthy one. Conductor of length L placed along the x-axis with one end at 0, other at L. Okay. Rate of flow of heat energy through the conductor is constant and thermal resistance is also constant. Then which of the following graphs are correct? So what we have, the rate of heat flow, that is H, the formula that we have is minus Ka dt by dx. Okay, so this H is constant, that means this dt by dx is going to remain constant. So dt by dx is going to remain constant, that means t versus x would be a straight line. And if the heat flow is constant, we can directly say the temperature will uniformly decrease as we go from higher to lower one. So as per the options, C1 seems to be the most appropriate one, because temperature will keep on decreasing from 0 to L. If we are assuming heat flows from 0 to L, if it flows from L to 0, then the temperature will increase from 0 to L. So going by the normal convention, this is the sort of curve we usually get. Now next one, that what we have, a diatomic ideal gas undergoes a thermodynamic change according to the PV diagram given in the figure. The total heat given to the gas is nearly, okay, so just look at this, A to B and B to C. A to B is what? This is isochoric and B to C is isothermal. So the total heat given to the gas, what we say, first of all, QAB would be NCV delta T. So if I do this, CV I know for a dia is 5 by 2. So 5 by 2 NR TB minus NRTA. Convert it into delta PV, which you have done many a times. So this is PBVB, which is 2 P0 V0 minus P0 V0. So what I get, 5 by 2 P0 V0 positive. Now for the isothermal one, what we say, QBC would be equal to W, that is nRT ln of V final upon V initial. So nRT I can put it from B, or you could put it from C, that remains the same. It is 2 P0 V0 and this would be ln2. So now what is the total heat received? That would be 5 by 2 plus 2 ln2 P0 V0. You are given the value of ln2 also. So 5 by 2 plus 1.4. So 2.5 plus 1.4, that is 3.9. I can make it out, and 3.9 is, it is wrongly written. It should be 3.9. I can make out there's some typo error. It should be 3.9 P0 V0 that we are getting. So go for option C. There's a typo. Next, cyclic process ABC is shown in the VT diagram. Okay. So first of all, A to B VT diagram, straight line passing through origin. It means it is isobaric. B to C is isochoric and this is isothermal. Now so check it. So A to B, first of all, constant pressure, temperature, volume increases. So this is appropriate. This one is wrong. This one appropriate. This one wrong. So left with A and C. So just see what's the difference in A and C. So what we have, this is definitely going to be wrong because C2A is isothermal. This cannot be possible. So we are left with only one option, that is option C, just by looking at it. So again, just you should be able to do these curve transformations. These are important in gases and thermodynamics. 6 moles of an ideal gas transforms a cycle shown in the figure if the temperature is T is 600, TB is 800, TC is 2200, TD is 1200. The work done per cycle is, okay. Again, look at the diagram, PT diagram. AB is volume constant. CD is also volume constant. First make it out. Now, so now we have work done in two process. We know is 0. So first calculate WBC isobaric. I can write it as NR delta T. You know, in isobaric for an ideal gas, P delta V can be written as NR delta T. So 6 into R into delta T, TC minus TB, that is 2200 minus 800, that is 1400. So 14 6 are what we have, 84. So 8400 R, positive work. And WDA, that is again NR delta T, the same result for isobaric. 6 into R delta T is TA minus TD, that is 600 minus 1200 minus 600, so minus 3600 R. So the net work done would be 84 minus 36, that 14, 6 and 8, 5 and 7 and 3, that is 4. So 4800 R, that is what I am getting. So if I do this 4800 R, R is generally you write as 25 by 3. In the table of 3, this comes out as 16. 25 into 16, 25, 6 are 150, 00, that carry is 25 into 1, 25, 40. so it is 40 kilojoule. I can easily go for option C, no issues in it. So simply calculative but a easy one. Next one, metal ball immersed in water weighs W1 at 0 degree, W2 at 50. The coefficient of cubical expansion of metal is less than that of water. Okay, coefficient of cubical expansion of water. So first of all, let me have the FB value. FB is rho of water into volume of the ball into G. So what we have, rho of water. So in the newer case, FB dash would be rho W dash VB dash G. So if I calculate FB dash and FB's ratio, what I have, rho W dash upon rho W into VB dash upon VB. Now rho would be 1 minus gamma of water into delta T, and this would be 1 plus gamma of ball into delta T. Okay, so most of the time, because it is less, we generally write it as 1 upon gamma B minus gamma W delta T. So looking at the data here, coefficient of cubical expansion of metal is less. Metal is less means this value is negative. That means FB dash by FB is going to be less than 1 on increasing temperature. So bind force will decrease, so weight will increase. So W2 would be greater than W1. I will go for option B. So it's a good question. Generally, people are not very comfortable in this particular concept. Next, if there are no heat losses, the heat released by the condensation of X gram of steam at 100 degree into the water at 100 degree can be used to convert Y gram of ice at 0 to 100, the ratio of ice to X is. So just remember, X gram of steam from 100 to water at 100, the heat released will be X into 540, and this is equivalent to water, ice melting into, okay, to convert ice at 0 to water at 100. So Y into, first of all, latent heat is 80. Just see, this is ice at 0. You first have 0 at water, so this requires 80 calorie per gram latent heat. Now 0 to 100, that is S delta T. S is 1, I take to 1 into 100, that is 100 calorie per gram. That is again I need. So what is I have, 80 plus 100, that is 180. So the ratio Y is to X is 540 upon 180. So it is a easy one. This is 3:1. Mostly you can remember also this result because of such questions you have already done. Now going ahead. Both the strings shown in the figure are made of the same material, have the same cross section. The pulleys are light. The wave speed of transverse wave in the string AB is V1, okay, and in CD is V2, okay. Then V1 by V2 is okay. So both are made of the same material, have the same cross section. That means the value of the mu is same. So you need to calculate the value of the tensions only. So V1 by V2, I can directly write it as root of T1 by T2. So let's T1 be the this tension AB, and this is T2. So going by our basic logic, because the pulley we always take to be massless and light, this is given. So I can directly say 2T1 would be equal to T2. So T2 is double. So that comes out as 1 by root 2. So it's an easy one for you. Option D, just basic LOM pulley measures. Next, the motion of a particle going along the x-axis on the y-axis is like this. Identify the correct statement. So comparing it to ut plus half at square, it means what we need, the initial velocity is okay. So simply if you have any doubt, just differentiate. There's no issue. That would be 3 plus what we will have, 10t minus 2. That is what we are going to have. So what we have, 3 plus 10t minus 2. So at t equal to 0, so dy by dt at t equal to 0, that would be equal to 3 minus 20. 3 minus 20 is minus 17 meter per second. So it is not 3. Speed would be at t equal to 2 seconds. Acceleration of the particle is 5. No, I can easily make out it is 10. Particle is at the origin at t equal to 2 seconds. So just check, t equal to 2 seconds, y would be 0. So it is option C is only correct. Rest are false. Next, go ahead. Particle is projected speed 20 at an angle 30 with horizontal. How much time the angle between velocity and acceleration will be 90? You all know the angle between acceleration and velocity is 90 at the topmost point. So topmost point time, you know, is equal to t by 2. T by 2 means uy by g. Uy by g means u sine theta. So 20 sine 30 is 1 by 2 divided by 10. So it's come out as 1 second. So again, a easy one if you can understand what the question wants to say. Next. A particle is projected along a line of greatest slope on a rough in plane inclined at an angle of 45 degree with the horizontal. If the coefficient of friction is 1 by 2, then retardation is okay. Then what is the retardation? So it is projected where? It is projected up along a line on a plane. It is going up. So because it is going up, friction acts down, mg acts down like this, vertical down, this is n. So simply what we'll have, acceleration would be minus fk plus mg sin theta upon m, and fk is mu k and n is mg cos theta, so that will come out as, if I solve it, mu k g cos theta plus g sin theta, that is the acceleration negative. So retardation value if I had to take mu k g I get, okay, mu k is also given, so just write the value of first mu k. So I take this g common, mu k is half into 1 by root 2 plus 1 by root 2. So what we'll have, we will have it as, if I take root 2 also common, it will become half plus 1. So going for the option C is the most natural choice for me. Now next one, 1 kg ball drops vertically into a floor, a height of 25, rebounds to 4, the coefficient is of restitution is. Now what I remember, if coefficient of restitution is E, V becomes C times U, or you can say the K final will become E square times initial. So energy would be E square times, I can directly say, and that kinetic energy at the highest points appears as the potential energy. So I can say U final at highest point would be equal to U initial at highest point times E square. Both heights are different, so let's call it H dash. So that is mgh, so I can directly say 4 is equal to 25 into E square, so E directly comes out as 2 by 5.4. That's my way of doing it. You can do by the way you knows what I can do. I try to simplify things using the knowledges of what we have already studied. Now, object comprised of a uniform ring of radius r and uniform chord AB, not necessarily of same material, which of the following cannot be the CM of the object? So this is a very general question that most of us have already seen. One object has an say CM at 0,0, the other one commons, by the common sense you can say, will be at r by 2, r by 2. So whatever be the material, first of all, due to symmetry, that it will lie on x equal to y, and x and y both coordinates will be less than r by 2 for sure. So they will be less than r by 2 for sure. This is less than, but r by root 2 is greater than r by 2. So r by root 2 cannot be the possible value of the CM, because CM cannot lie beyond this. So that is the clear-cut option that we have. Next one, 22nd. A man of mass 80 kg riding on a small cart of mass 40 kg which is rolling down a level floor at a speed of 2. He is running at a cart so that his velocity related to the cart is 3 in the direction opposite to the motion. What is the speed of the center of mass of the system? Okay. So the cart goes at speed 2 meter per second. Men with respect to cart is 3 meter per second. So let's assume the velocity of men here is v with respect to ground. So what is the velocity of men with respect to cart? We say is Vm minus Vc. So this Vmc, I take this direction as positive. So Vmc is minus 3, that is equal to Vm minus Vc, that is 2. So Vm comes out to be minus 1 meter per second, that is it is going 1 meter per second backwards. So now the VCM would be men's mass is 80, its velocity is minus 1, cart is 40, its velocity is 2 upon 80 plus 40, 120, that comes out as 0. That means CM is going nowhere, CM speed is 0. Okay, next one. A ball going on a horizontal frictionless plane hits an identical ball at rest with a velocity of 50. If the collision is elastic, calculate the speed imparted to the target ball. If the speed of the striking ball after the collision is 30. Okay, so what you are given, hits an identical ball at rest with a velocity of 50. If the collision is elastic, calculate the speed imparted to the target ball. So first of all, it cannot be the 1D collision, otherwise full speed will be imparted. So it might be a 2D one. So we'll simply go by kinetic energy. What we'll say, K1 initial would be equal to K1 final plus K2 final, because K2 initial is 0. So K1 initial is half m into 50 square. I am not changing units because it would be same. That would be equal to half m into 30 square, because it is identical mass would be same, that is V2 square. So this m half. So V2 is directly you can write out here 50 square minus 30 square under root, that is 40 centimeter per second. So it's an easy one for you, though it seems different, because for identical balls, for 1D collision, we know the complete velocity would have been transferred. Keeping the angle of the banking of the road constant, the maximum speed of the road is increased by 10%. The radius of curvature of the road will be changed. I remember this question every time, but let's say I'll solve it for you. We have tan theta is equal to V square by Rg, that is the expression you remember for the perfect banking speed. So angle is same, and the radius of curvature of the road has to be changed. That means v square by r will remain same, so v1 square by r1 would be equal to v2 square by r2. So the new r2 would be v2 by v1 whole square times r1. So now v2 is 10%, that is 1.1 times v1. Okay, 100 plus 10, 110, you can say square into 20. 1.1 square is 1.21 into 20. So this is what I get is at 24.2 meters. Go for option C, no other choice. Now, next one. If the kinetic energy of a satellite, of an orbiting satellite around the earth is doubled, you know kinetic energy doubles. Initial kinetic energy, it has k. If you give k more, this is equal to its binding energy, because the total energy, you know, total energy, you have the idea of satellite is minus k. So if you give plus k, energy becomes 0, so it will escape into the space. That we always remember this fact. Easy one for you. Next. Two satellites have the ratio of their masses 3:1, circular orbit r and 4r, the ratio of the total mechanical energy. Okay, so we know the energy is, just remember the formula, minus gmm by 2r. So m, okay, mass ratio is given, this is mass of the planet, which would be same, so energy ratio would be proportional to m by r. So if I have to do ea by eb, it would be ma by mb, and here I can write it as rb by ra. So MA by MB is 3:1, RA by RB is so different ratio 4:1. So what we'll have, it is 12:1. Go for option D. Now, next one. To study the dissipation of energy of the simple pendulum, student plots a graph between square root of time and amplitude. The graph would be, okay. Now this is, you have done as a, what we say, an experiment, and where you plot amplitude square with time and you find that is hyperbola. So you remember from that fact that a square t remains constant type of thing. So if I plot a graph between a root t, that will also be a constant, and that is also going to be a hyperbolic curve. Just remember this. So it might be tough for you if you don't remember, but this is what there is an experiments also based on this that you have to do. Okay, now going ahead, what we have next is, we have question number 28. So looking at the question, what it is, first of all, this is 28. If the same weight is suspended 3 spring having the length 1:3:5, the period of oscillation shall be in the ratio. Okay, same weight, what we know, t is 2 pi root m by k. So m is same, so it is 1 by k. So this ratio would be root of 1 by k. So this t1 is to t2 is to t3 would be, what we have, 1:1 is to 1 root 3 is to 1 root 5. So doing it, what we will have, as per the options, if I go, it is having length. Okay, it's my mistake, it's the length, not the spring constant, and what we know generally k is inverse to L. So this will become proportional to root L. So now what we have, 1 root 3 to root 5. Just remember like this. So read the question carefully. So it would be option B. Now, a U-tube of base length L filled with the same volume of two liquids density rho and 2 rho is moving with acceleration A on a horizontal plane. If the height difference is 0, okay, then the height h is given by, okay, if the height difference between the two surfaces open to atmosphere becomes 0, then the height h is given by. So just remember, consider this section only, this one, from here to here. So if I take this section here, if it is going with acceleration A, I'll write the pressure here. Here the pressure would be P naught plus density, let's say rho gh, and here what we have, the pressure, here we have the pressure is equal to 2 rho. 2 rho, that means the pressure there would be equal to P naught plus 2 rho gh. These would be the pressure at the two sides. Okay, because it is going forward, it means definitely this will be the denser one, this would be the lighter one. So the difference of the two pressure into area, that would be rho gh into area, that is equal to ma. And what is the m? So this length, what we have, this length is L, so L by 2. So I have rho mass I'll take, it would be rho a into L by 2, and this is 2 rho into a into L by 2 into a, that is what I'll have. So a and a get cancelled, this rho cancelled. So gh is equal to L by 2 plus L into a. So the value of h is coming out as 3LA by 2G. So it is option B. That is what I can make it out, because for the horizontal section the net force should be equals to mass times A. So that is what I am writing it out. Now go ahead. The work done to get n smaller equal size spherical drops from bigger size spherical drop of water is proportional to, okay, so we have a single drop and now we break it into n small drops. Now what would be this work is proportional to? So first of all, volume equation will mean 4 by 3 pi r cube would be small n into 4 by 3 pi r cube. You remember this means small r would be n to the power 1 by 3, or you can say, sorry, not a capital R is like this, so you can write capital R as n to the power 1 by 3 times small r, first thing. Now work done would be, let's say, final energy, final area of a drop is 4 pi r square multiplied by n. Original area was again 4 pi capital R square, not 8, because that would be for bubble. 4 pi r square into surface tension, let's call it S or T, whatever you write. I'm writing it T. So if I do this r square, so that work required is proportional to, we need to remember, so get it into the terms of n. So I can write it as 4 pi r square, small r is r square, upon this would be n to the power 2 by 3 upon n minus 4 pi r square t. So what we have now, we have this as all factors, I can take it out common, it would be n to the power 1 by 3 minus 1. That is the result I am getting here. So it is proportional to n to the power 1 by 3 minus 1. Okay, so this is option C we are going for. Next one, what we have, relation between L and R of the cylinder if the moment of inertia about its axis is equal to that about the equatorial axis. Now this is a very good question. This is a cylinder, its axis means this one, and that you know is equal to, because it is a cylinder, I'll take it as mr square by 2. I'm taking it as a solid cylinder, not a, what we say is the hollow one. Now about the equatorial axis, this one, this is interesting. About this, we take of this the example of the disc. This one is mr square by 4 plus added to the what we say for the rod ml square by 12. This is the formula that you should remember. If you want to derive, go for x, take a small thin disc dx, write it semi mr square by 4 plus dm into x square, and integrated it would be like this only. So both are equal, that means mr square by 4 plus ml square by 12 is equal to mr square by 2. I get m and m cancelled, doing it here and there. L square by 12 would be equal to r square by 4. L square is equal to 3r square, so L is equal to root 3r. Go for option D. So it's a good question if you remember that formula. Now the circuit shown in the figure contains two diode D1 D2, okay, with forward resistance. So in forward bias it also have a resistance of 50, and in finable don't connect in reverse bias. Now if the battery is 6, the current through the 100 ohm would be, okay. So first of all, this D1 is forward bias, D2 is reverse bias, this branch won't work, so only this is the loop that is working. So effective resistance of the circuit R total, if I write, so this is 50 of the diode plus 150 plus 100, so what I get, 300. So the current, the complete current will pass through 100, that is through the battery, that would be equal to 6 by 300. I should write it as 6000 by 300 milliampere. So this would be what I will have, this would be what I will have, 20 milliamperes. 20 milliamperes means 0.02 ampere I can directly go for. So not a tough one, you can make it out this that much. Next one, a sample of radioactive material decays simultaneously by two processes, so that is a parallel or concurrent decay. Half-lives half and 1 by 4 hours respectively. For first half hour it decays with process A, next 1 hour with process B, and for further half so it is a very mix and match. So first of all, for the first half hour, let's say it was N0, so for the first half hour this is with A whose half-life is half, so it will become N0 by 2, okay. So this is N0 by 2. Now for next 1 hour with B, 1 hour for B means 4 half-lives. 4 half-life means this will become 1 by 16 of N0 by 2. That will be, I should write N0 upon 2 to the power 5 now. Now for next half an hour by both. Now by both, so the effective half-life in this case would be 1 by T1 plus 1 by T2, because effective half-life will decrease, that is 1 upon 1 by 2 plus 1 upon 1 by 4, that is 6. That means T half will be 1 by 6. So half-life is 1 by 6 hours if it decays by both. So in half an hour we will have 3 more half-lives, so it would be 1 by 2 by 3 into what we have originally, and not upon 2 to the power 4. So go for option A. So it's a good question, but you need to be very clear that how you are reading it. Next one, Imagine an atom made of a nucleus of charge Z and a hypothetical particle of the same mass but double the charge of the electron. Okay. Apply the same Bohr model and consider all possible transition of that hypothetical particle to the ground state. The longest wavelength of the photon that will be emitted has a wavelength lambda given in terms of Rydberg constant RH of the hydrogen atom. Now here I always advise my students to remember that 13.6 eV that you get, that is basically given by m e to the power 4 8 what we have, if I can recall, h square epsilon naught square. Okay, so this is proportional to e to the power 4. Here the e square is for the proton and e square is for the electron. So what you have here, that electron particle has double the charge, so this factor become 4 times. So instead of 13.6 I will have this factor multiplied as 4. So for ground state, maximum wavelength mean n equals to 2 to n equal to 1. So I can directly write using Rydberg formula 1 by lambda is what we typically write as rz square. Here I will put the factor 4 also because of that thing. So that would be 4 rz square 1 upon 1 square minus 1 upon 2 square. So that is what I can do. So just remember this. If you don't remember this, it becomes really tough to solve now. Now what we have now, this is 4rz square that we have, and this is what we'll get 3 by 4. This 4 and 4 get cancelled. So lambda would be 1 upon 3z square r, Rydberg constant RH, whatever you write. So this is option B. So if you remember that particular thing, always say energy expression should be remembered like this. This one was the expression, and I break down that E4 into this thing. Okay, next one. So this is going to be a challenging one, I know. The magnitude of energy of the electron in nth Bohr orbit is En, and Jn is its angular momentum. Then okay, that is angular momentum, that is energy. First of all, energy what we had, what we write as RHC z square by n square. J, angular momentum. First of all, what is the angular momentum here? That is mvr, which is always equal to nh by 2 pi. Okay, so now what we have now, if I do this from here, I can directly say E is proportional to 1 upon Zn square using that n square proportionality, because E is proportional to 1 by n square, J is proportional to n. Okay, next. The threshold frequency of a metallic surface corresponds to an energy of 6.2, okay, and stopping potential for a radiation is 5, the incident radiation. Okay, so that means the energy of the radiation is 6.2 plus 5, Kmax would be 5, so 6.2 eV plus 5 eV, that is 11.2 eV. So if I do the lambda is 1240 upon 11.2, this would be nano. So it is approximately 110-20 something, 110-20 nanometers sort of thing that I can make out, and this is lesser than your visible one. This will definitely be lying in the UV region, so go for option A. Next, the ratio of the maximum wavelength of the Lyman to the maximum wavelength in the Passion. I think the same question we did it tomorrow or something, but let's again do this. Maximum of Lyman, so 1 upon lambda 1, let's say I call it maximum of Lyman, that would be equal to R 1 upon what we have. Lyman is 1 square, we have the maximum, so 1 square minus 2 square. And for the Passion, Lyman, Balmer, Passion we had, so for Passion what we have R, this will become 4 to 3, so 1 upon 3 square minus 1 upon 4 square. So if I do the reverse ratios so that I get lambda 1 by lambda 2. So what I will get, 1 upon 3 square minus 1 upon 4 square, 1 minus 1 by 4, I can write like this. So 1 by 9 minus 1 by 16, that is 7 by 144. Here what I will get, 3 by 4, 7 into 4 into 3 upon 144, that is what I am getting, if I am right. Yes, so 4, 4, 4, 4, this is 30, 36, the 7 upon 108. The same question came a few days before, or maybe yesterday, I don't know. Next one, if A and B is given in figure, then output will be okay. What would be the output? This is first to identify which gate it is. You all know this is the AND gate. So only one will be when both are 1. So these two instant will be 1, otherwise all will be 0. So whatever I am getting only option A as the correct one. So you get, that was an easy one. The maximum NOR gates that are required to make one NAND gate. Okay, so minimum, sorry, not maximum. Questions always ask for minimum. So the minimum number of NOR gates that are needed. Now just recall how you make NAND. So I remember how I make the AND gate first of all. So I know AND gate was made something like this. That generally we remember. This is the input is being fed like this. This is A. Same input you can feed, or you can have two inputs, whatever you can have, A and B. You can draw it like this also. Both are feed A and B. So what we get here, A bar, what we get here, B bar. And if I do that, because it's an OR gate, what I'll get here A bar plus B bar ka whole bar, and this A bar plus B bar ka whole bar gives you AB. Now to get NAND, you need to have an inverter, and to an inverter simply give to both inputs like this. This would be the reverse of that. So reverse of that means AB bar. So here we can see the number of gates we need is 4. So 4 gates are required. Next one, in a transistor the EBC are respectively, okay, that's an easy one. Base is least doped, emitter is highly doped, collector is moderately doped. So what we have, the first one seems to be the most appropriate one. We need not to read further. Next one, again semiconductors. To get not semiconductor now, to get maximum current through a resistance of 2.5 ohm, one can use m rows of cell, each rows having n cells. The internal resistance is 0.5, the value of it is 45. So what we know, the R equivalent of the battery should be equals to that R. We know 2.5. So what it is, we have n cells, so nr and m rows, so nr by m should be equals to 2.5, and what you know, m into n is equal to 45. So first of all, m into n is 45, and from above, n upon m comes out as 2.5 upon 0.5, that comes out as 5. So what we have, we need to go for the how many cells, 45 cells. The ratio is 5, product is 45. I can make it out as 15 into 3. So n is 15, m is 3. Similar question I think we did some time back. Okay, so what we have, n is equal to 15, not m, sorry. Whatever from this, n is greater, so don't do such mistake after solving all this. M is 3, n is 15. Okay, next one. What now, I have 3 prism are combined, the refractive. So just remember this dispersion thing, crown glass for red, yellow, this. No net angular dispersion. So no net angular dispersion means the net dispersion, first of all we need to go for the red and the violet one. Yellow won't be required. So first of all, the deviation done by this crown glasses, it would be 2 times, that would be equal to 2 times mu r minus mu v, or what I can write, mu r minus mu v, or mu v minus mu r, sorry, we generally write mu v minus mu r, mu v minus mu r into a, and that should be balanced by this, because it would be rotating in opposite direction. So that would be mu 1 dash minus mu r dash into a dash. So that is what we have. So the ratio of a dash to a would be 2 times mu v minus mu r upon mu v dash minus mu r dash. So question looks difficult, but it's not difficult if you are thorough with the concepts. It's an easy one if you know that. If you don't know that, then I can't help. The refractive angle 60, minimum deviation is 30, the angle of incidence will be, again this question is getting repeated. What we have, just refracting angle is 60, minimum deviation is 30. So first of all, calculate the value of n from the basic result that we have, or we need not to calculate that also. Just remember, angle given, minimum deviation is given. So generally deviation you know is equal to I plus E minus A. So in the case of minimum deviation, you remember this formula, 2i minus a. So 2i is del min plus a, which is 90. So I comes out as 45. This is also a repeated question. We have done it a few tests back. Next again. Consider Fraunhofer diffraction pattern obtained with a single set illuminated at normal incidence. At the angular position of the first minima, the phase difference between the wavelets from the opposite edges. And now this is an interesting one. If you can recall the first minima was recalled using this fact that the source just below it and just below the mid of it has a phase difference of pi and get cancelled. So opposite edges mean this gap was pi, this gap will also be pi, so pi and pi will become 2 pi. So that would be the answer. This is the question that has already been asked in examinations. Don't go for pi, it would be 2 pi. Next. Plane polarized light is passed through a Polaroid. On viewing through the Polaroid, we find that when the Polaroid is given one complete rotation, one of the following is observed. Because the light is already polarized, on complete 360 rotation, there would be 2 instants when it will become 0. So it will become 0 at 2 times. So intensity of light would be 2 times 0 and 2 times maximum. So go for option D. That is the most appropriate one that we have. So students, this was the today's paper. So keep sharing this channel, keep subscribing, liking the videos, doing your comments. Thank you. We will continue with this series till NTA keeps releasing the paper every day. Okay.